Looking at the specimen, we have a captivating example of a mineral aggregate, a beautiful assembly of distinct crystals that tell a story of geological processes and conditions. Let's delve into the details and appreciate the complexity of this sample. Firstly, observe the vibrant green crystals that dominate the specimen. These are likely olivine, a magnesium-iron silicate mineral known for its distinctive green hue. Olivine is commonly found in mafic and ultramafic rocks, often associated with volcanic activity and meteorites. The crystals here appear to be well formed, suggesting a relatively slow cooling process that allowed them to develop their characteristic shapes. The color variation within the olivine, from lighter to darker greens, may indicate slight differences in composition, with more magnesium-rich olivine tending towards lighter shades. Interspersed among the olivine are striking black crystals, which are likely pyroxene, another silicate mineral common in mafic and ultramafic rocks. Pyroxene often forms under high temperatures and pressures, and its presence here indicates that this sample may have originated from a deep mantle source. The sharp, well-defined edges of the pyroxene crystals suggest they too have had time to grow, further supporting the idea of a gradual cooling process. The specimen also features a matrix of lighter, more fine-grained material. This could be a mixture of smaller crystals or a ground mass of rapidly cooled volcanic glass. The presence of this matrix suggests that while some minerals had time to form large, well-defined crystals, others cooled more rapidly, creating a varied texture within the sample. Notice the small orange, brown patches scattered throughout the specimen. These could be areas of alteration, where primary minerals have been changed by hydrothermal fluids or other secondary processes. Such alterations can provide valuable insights into the later stages of the rock's history, revealing how it interacted with its environment over time. The overall texture of the specimen is what geologists refer to as porphyritic, with larger crystals, phenocrysts, embedded in a finer, grained ground mass. This texture is typical of igneous rocks that have undergone a two-stage cooling process, with the larger crystals forming first under slower cooling conditions, and the ground mass forming later as the remaining material cooled more rapidly. In summary, this specimen is a fascinating example of an igneous rock, likely of mafic or ultramafic origin, featuring a beautiful assembly of olivine and pyroxene crystals. Its porphyritic texture and signs of alteration provide clues to its formation and history, making it a valuable subject for geological study and appreciation.